Hi guys, welcome back to a brand new episode of Wonders Are Decoded. Guys, did you know the history behind the Eiffel Tower? It may sound unlikely, but the Eiffel Tower was never intended as a permanent landmark. It began as a temporary entrance arch for the 1889 World's Fair. It was planned to last only for 20 years, a 300-meter experimental structure with an expiration date. So how did a structure designed for disposal become a global economic icon? Even though Gustave Eiffel was not behind the original idea, but to the public, he became the face of the project. Eventually, the real history, like the tower, has hidden structure. The story of the man who got the credit is only half the story. The tower was not the brainchild of a single man. It was born from the minds of a team. They were the chief engineers of Eiffel's company, the experts who dreamed up the pylon of over 300 meters. The first sketch was drawn in May 1884 by Maurice Koechlin and Émile Nouguier. Their initial drawing was a raw, skeletal concept, a feat of pure mathematics and structural logic. It was their calculations that proved such a tower could stand against the forces of wind and its own immense weight. Eiffel initially called the design a giant pylon and showed no interest. Koechlin and Nouguier then went to the company's head of architecture, Stephen Sylvestre. He looked at the design and realized that for this tower to be accepted, it needed more than just strength. It needed grace. On the original design, Sylvestre added the decorative arches at the base and the glass pavilion to make it look less like a bridge and more like a monument. He also designed the pavilions on the first level, the dome top. Sylvestre transformed a stark engineering diagram into an architectural statement, giving the iron skeleton a sense of elegance and form that softened its industrial might. This is the hidden story of the tower's creation. Eiffel looked over again at the design and decided to bought the patent rights from his own employees to become the sole owner of the design. His name was now attached to the project, and it would be his name etched into history. Now the question is, who was Gustave Eiffel? He was a bold entrepreneur who took on the monumental risk and staked his reputation on its success. He was a brilliant engineer, a master of metallic structures known for building bridges that spanned impossible distances. But building Eiffel Tower was no smaller feast. It is a story of collaboration, silent geniuses, forgotten builders who would later risk their lives to assemble it. So how did this team turn a hated blueprint into an icon? How did they overcome the technological limits of their time, the political battles, the relentless public scorn? To answer that, we must go back to the beginning. We must decode the engineering, uncover the controversies, and reveal the people who fought for a tower that nobody seemed to want, yet the world could not forget. The story of the tower begins not with a sketch but with a challenge. Paris was preparing to host the 1889 Exposition Universelle, a grand World's Fair marking the 100th anniversary of the Revolution. It was a moment to declare France's industrial and cultural might. The centerpiece had to be spectacular, something no one had seen. The government launched a competition, inviting the greatest engineers, architects, to submit designs for a temporary monument on the Champ de Mars. One simple rule: it had to be tall. A 300-meter tower. The idea was audacious, almost fantastical. During that time, the tallest structure was the Washington Monument, a stone obelisk just over 169 meters. This new tower would be nearly double that height. The competition ignited imaginations. Over 100 proposals arrived from all over the world. Some were bizarre: a giant water sprinkler to cool the city. Others were monumental: a massive stone tower that would have collapsed. Many were dismissed as fantasies. But one design stood out, not made of stone, but of iron. The proposal came from Gustave Eiffel's firm. He was a celebrated engineer, a master bridge builder. While others were rooted in the past, he moved into the future. A lattice of iron, incredibly strong, surprisingly light. Born from bridge engineering logic, applied vertically at an unprecedented scale. A machine for reaching the sky, it captured the jury's approval immediately. Thousands of pages of calculations, proving stability, detailing construction, not just an idea, a solution. In June 1886, the contract was awarded. Gustave Eiffel would build the 300-meter tower. Winning was only the first step. He had to convince a skeptical city, navigate political opposition, assemble a team to build it. The plan was in place. The battle for its creation was about to begin. The first problem was the soft soil. The Eiffel Tower sits on the banks of the River Seine. Two of the four legs, north and west, were only meters from the river. The ground was not solid earth but waterlogged silt. Eiffel didn't just dig. He used 16 watertight pneumatic caissons, massive iron boxes. Compressed air was pumped in to keep the water out, allowing men to dig by hand in a pressurized environment below the river level. The caissons were sunk through 5 meters of mud until they reached a layer of compacted gravel and bedrock. If these hadn't reached that specific geological layer, the tower would have leaned or collapsed into the River Seine within years. Mathematically, if the four legs were off by even a few millimeters as they slanted inward, they would never meet at the first platform, 57 meters up. This was the same technique used for the Brooklyn Bridge. Eiffel placed each leg on a hydraulic jack operated by hand pumps. This allowed him to lift or lower each of the 800-ton legs independently to ensure perfect alignment. Once the first platform was joined, the jacks were removed and replaced with permanent steel wedge. Back in 18th century, there were no complex mathematical formulas for wind loads at 300 meters. Eiffel totally relied on his bridge builder's intuition. The tower's unique curve is actually a physical graph of wind pressure. The curvature of the legs is designed so that the bending moment of the wind is perfectly balanced by the weight of the iron itself. It was an engineer's solution, stark and unadorned. Because of this design, the tower is incredibly light. If all the iron were to be melted into a solid block to the size of the base, it would be only 6 centimeters tall. The air inside the tower weighs more than the iron framework. Gustave Eiffel knew that for a public monument, engineering was not enough. The tower had to have an emotional appeal, a sense of grandeur. Eiffel didn't use steel. He used puddled iron, wrought iron from the Lorraine region. It was more flexible and easier to rivet. The entire construction of the tower was an industrial orchestra. Each of the 2.5 million rivets required a specialized four-man team, one to heat it red hot, one to hold it, one to shape the head, and one to hammer it. The rivets were inserted hot. As they cooled, they contracted, pulling the iron parts together with a force no bolt could match. This is why the tower remains stable even as it expands and shrinks by up to 15 centimeters, 6 inches, in the summer heat. Every piece was pre-drilled to an accuracy of 0.1 millimeter in his factory in Levallois-Perret. The riveters, 2/3 of the rivets were done in the factory. Only 1/3 were hammered in 300 meters in the air. Factories roared as Paris supplied iron and coal. Design teams coordinated shipments and schedules. Daily templates ensured each plate matched with precision. Rails carried parts across bridges into the city. On-site, crews staged pieces for assembly workers, fitted lattice segments under strict supervision. Machine shops shaped members to exact dimensions. Planners mapped every bolt position meticulously, and drafters updated drawings periodically. As tolerances were checked, the foremen signed off before lifting each section. They calculated the stress on every single beam, the angle of every joint, the placement of every one of the 2.5 million rivets that would hold the tower together. They were the silent architects, translating the grand vision into a precise mathematical language. It was their painstaking work that ensured every piece would fit perfectly, and that the tower would stand tall and true against the forces of nature. Up close, the iron lattice reveals where millions of rivets locked this tower into a single breathing frame. Crews worked like a human tower, each roll lifting the next in a disciplined, repeatable rhythm. Across the city, workshops cut, drilled, and labeled parts bound for assembly on the Champ de Mars. Iron bars were heated to a cherry glow, the precise softness needed to shape unforgiving puddled iron. Sparks fly as edges are prepared and plates fitted tight, ready for the riveters' closing blows. A white-hot rivet is caught, set, and hammered into a perfect head before the metal cools. Hydraulic hammers drive stubborn pieces flush, ensuring tight joints and even paths for force. Paris watched as iron from distant foundries arrived by barge and rail to feed the rising frame. Piece by piece, the skyline shifted, the legs climbing steadily above the city streets. Industrial presses punched and pre-drilled holes to within 1/10 of a millimeter. In the foundry, molten iron became plates and angles, each stamped and catalogued for its exact place. Rivers of glowing metal were cast into members later drilled, matched and riveted high above Paris. Safety crews inspected scaffolds, hoists, and gear before each climb to keep the rhythm unbroken. Every gusset and diagonal brace channels wind through the lattice and down into the foundations. On site, crews aligned parts, pinned them in place, and readied seams for the rivet teams. Foremen tracked progress with gauges and lines, correcting any drift as the height increased. Accidents were rare but real, and the work honored those who risked everything to build it. By spring, the iron giant surged higher, each hammer's echo rolling across Paris. As winter set in, crews broke ground for the first floor footings on the frigid Champ de Mars. Snow and icy winds slowed deliveries, forcing shorter shifts and constant thawing of equipment. Ice formed on scaffolds and tools, making every step and surface a hazard. Work sites were blanketed in snow, and progress crawled between storms. Days slipped by on the calendar as weather delays piled up. Still, crowds gathered to watch the iron skeleton inch upward through the cold. Newspapers tracked each milestone, praising ingenuity and questioning the schedule. Early service towers and stair platforms went up first to access the rising legs. Night work continued under lamps, as crews pushed to keep the timeline. By early spring, the silhouette was unmistakable. Paris's new giant was finally taking shape. Inspectors walked the members, checking rivets and bracing after every lift. From base to sky, surveyors verified the alignment of each leg daily. Precision ruled the build. Tolerances was measured to the millimeter. Machines clanked and compressors hummed to power drills and hoists. Workers pumped the massive leveling jacks with foot pedals to nudge the legs into line. Fine adjustments on site brought prefabricated parts into perfect fit. The teams assembled nodes like clockwork, tightening sequences to avoid twist. Power from temporary grids and wind gust checks guided when the next lift could proceed. The joints were detailed like timber carpentry, transferring loads cleanly between members. And the towering cranes swung iron pieces into position with practiced rhythm. While looking up through the lattice, the logic of forces and flow was visible. So when the first platform locked, the crew cheered. Their precision had paid off. Engineers posed proudly, noting deflection readings well within design. With cranes still busy, the project surged ahead toward the second level. Spring brought unpredictable gusts that stalled the lifts. Engineers measured sway and recalculated tolerances daily. Crews tightened braces, then paused when wind spiked. Crane operators waited for safe windows between gusts. Every hoist depended totally on wind flags and barometers. And from above, Paris watched steel choreography in air. The plans detailed sequences that minimized time aloft. The lattice shape shed wind instead of fighting it, and the cloud shadows raced the growing outline across Paris. Riggers clipped lines, ready to lock members instantly. The drafting tables updated angles after each wind reading. Trees bent below, as they are warning crews to hold position. Mathematics clearly guided them when to climb and when to wait. The tests proved that the curve distributed pressure efficiently. Foremen coordinated lifts with whistles and hand signals. The streets funneled equipment toward the Champ de Mars. The teams were rotating shifts, keeping focus sharp and under strain. Clear days advanced meters. Storms, however, erased several schedules. Timekeeping mattered was crucial as each delay recalculated the plan. Time-lapse hid the patience required between lifts. Despite tempests, the tower kept rising, line by line. Guys, if you think the challenge was just about stacking iron, you haven't decoded the full picture yet. We are only halfway through this industrial gamble. We have seen how the foundations were won against the river, but the most dangerous part of the vertical climb, and the secret that saved this tower from the scrap heap, is still to come. Stay tuned for part 2 as we finish this decoding journey of the Eiffel Tower. Thanks for watching, and if you have any questions, let us know in the comments below.